All right, guys, happy Monday. I hope you all had a safe and relaxing weekend. Before we jump into our unit on nuclear chemistry, we do have to do a bit of reviewing with isotopes. We reviewed these a bit in the beginning of the year, but this week we're actually going to become masters at them. So today we're just going to kind of review what an isotope is and kind of relearn how to recognize what an isotope is and how to calculate the mass for an isotope. So I wanted to start out by somewhat exposing myself and starting with an analogy. So here I have an isotope Miss Gladden. If you guys forgot what an isotope is, it's the same element, but it has a different mass, meaning it's going to have the same number of protons. So if it has 6 protons, it's always going to be carbon. It could have a mass of 12. It could have a mass of 14. It could have a mass of 16. That just means the number of neutrons is different. Carbon, again, 6 protons, still carbon, but it could have a different number of neutrons, making it a different mass. So here is myself as an isotope. So here I don't know how old I was. I was like 5, and I couldn't find any pictures where I wasn't making a weird face. So let's say here I was about 50 pounds. There's me, Kelsey, 50 pounds. And then here is my high school graduation. So let's say here I was, about 120 pounds. Still Kelsey, but I'm a different mass. Continuing with my isotope, here is my college graduation. I want to say I was about 130 pounds here. And then here's a current picture of me trying to hike up a mountain and struggling. Not really sure how much I weigh now after quarantine, but let's say I weigh about 135 pounds. Still Kelsey, just a different weight, and that's exactly what an isotope is. So today we're just going to kind of review. You guys have seen these before. We did a bunch in class. I want to say October, November. Let me see if this will focus. Sorry guys, it's not focused. There you go. All right, so we're going to do isotope examples. I'm going to give you, actually, hold up. I'm going to do these for you, and then you're going to have about 3 to do on your own. I'm not going to answer this question for you because I want you to put it in your own words. Remember what an isotope is and how exactly you could tell them apart. Think about me as an isotope. How could you tell me apart from 50 pounds to 120 pounds? I was still Kelsey, but what was different about me? So let's look at this example. We're just going to fill in these boxes today of different isotopes. So here we have carbon, but we have carbon 12, and we're going to write it with the mass. So that means it has a mass of 12. And we also have carbon, same element, but 16. Number of protons. You're definitely going to need your periodic table, so whip it out. Again, I'm going to bring out my friend from high school. So we have carbon, and here we have 12. And guys, on the periodic table, the mass is just an average of all the different isotopes that are found in nature. So carbon, the number of protons, always going to be 6. So this box is always going to be the same across. We have 6 protons. That is what gives it its identity, the number of protons. Now, we're going to assume they're always neutral, so I'm going to jump ahead and do the number of electrons. So I know it's neutral, meaning the protons and electrons are the same. They're going to cancel each other out. We don't have an ion. Now to get to the neutrons. In order to determine the number of neutrons, remember, we have a mass, which is protons plus neutrons. A couple of you have it written on your periodic tables, P plus N equals mass. So we know the mass is 12. How do I identify the number of neutrons? Well, I know the protons are 6, so I'm going to write down that equation. Mass equals P plus N. I have the mass, I have the protons, I need to find neutrons. So I can rearrange this equation. N is going to be the mass minus the number of protons. So let me plug that in. So I know my mass is 12. and I'm going to subtract the 6 protons from that mass number to get a neutron number of 6. That makes sense. And then you could double check 6 plus 6 should equal 12. Now we have carbon-16. This is an isotope. Same element, just a different mass, meaning it has a different number of neutrons. So we're going to take 16 and we're going to subtract the protons from it. This time we have 10 neutrons in this element. There are my 2 isotopes of carbon. All right, we're going to do the same thing for the next 2. Again, here, I just gave you the mass numbers, and you need to determine what's the protons, electrons, and neutrons. Again, you're going to need that periodic table. So let's find chromium. That is a transition metal. So let's find him. He's here. He is always going to have the identity of 24 protons. So I'm going to fill in this box, 24, 24. And again, I'm going to jump down to the electrons, assuming it's neutral, 24, 24. And now I have to determine the number of neutrons. So I have to subtract my proton number from my total mass. So I'm going to take my calculator. I have 58 minus my number of protons. I got 34 neutrons in this isotope of chromium. And now I have a different isotope, meaning same element, different number of neutrons, different mass number. So I have 63 this time. So let me take 63. And again, I'm going to subtract that same number of protons because, again, it wouldn't be chromium if it didn't have 24 protons. If it only had 23, we would have, let me see, vanadium. I don't know if I said that right. But if we had 25, we would have manganese. See how the proton number changes the element completely? We're not changing the element. We're just changing the mass. So 63 minus that 24 protons. This isotope has 39 neutrons. Hopefully y'all are getting the hang of this. Let's jump ahead, do the last one. This time I gave you the number of neutrons and the number of electrons. And remember, I said we are going to assume that they are always neutral. So if I have my number of electrons, I definitely have my number of protons. So I have 55 protons, 55, and this isotope we're going to assume is still neutral. So 55 all along. But how do I determine what element I have? Well, I know the proton number, therefore I know the element. Let me just take a look at my periodic table, find proton number of 55. Here's my proton number of 55. I have cesium here, but I need to write it with its mass. So I have cesium. I have 2 isotopes of cesium here, and I'm going to write it with the mass. The mass is just P plus N. So I'm going to take the number of protons plus the number of neutrons. So here I have isotope of cesium 55 plus 113. I have cesium 168. And then here I have 55 plus 111. So I'm going to have an isotope of cesium 166. And I think cesium has a ton of different isotopes. But that is just a general example. Today we are just solely focused on how to determine the mass of an isotope and identify what isotope we have. All right, great. So on Google Classroom, you are going to have a worksheet. You can either print it out and write directly on it, or you can type in the answers and submit it for a grade. Haven't determined whether I want to make this a homework or a quiz grade. If everybody does really well, I probably will make it a grade boosting quiz. All right, guys, remember to reach out if you need any help. Watch this video a couple times if you need to. We're going to talk all about isotopes all week. Good luck.